Hey everybody, welcome back to another fun and exciting Algebra 2 class. This class is just a continuation of the last lesson where we were in lesson 7.4 and we were expanding logarithmic expressions. The other thing that we were doing is just talking about the different rules, properties of the logarithmic expressions. And so let's just keep going with that thought. And now what we're going to be doing is condensing them. To condense means to make smaller. So we're going to take the big expression and we're going to move it back down. Let's just take a look at an example right here. Look down here, log 3x plus log z. That's a z, by the way, not a 2. So let me kind of cross that. There you go. All right, well, what we want to do here is now, because it's adding, just like before when it was multiplying, we added. Now when we add, we multiply. So we're going backwards. We're taking the property, the product property in this case, and we're going backwards. So what's this one going to look like? Well, we're going to condense it down. We're going to make it smaller, and we're going to do log 3xz, and that's going to be our answer, 3xz. All right, it's actually fairly easy, once you get it down. I don't like to say that things are easy in Algebra 2 because they're not, but this concept, I said it's fairly easy. Okay, so if you got the expanding, then you should be getting the condensing. And this is on, if you're looking where this is on page 347 in your book. I'm following along in those examples there. All right. The next one is, let's do this natural log problem. And again, we notice that we have a big expression. It's got a plus or minus sign in it, and we need to condense it down. Notice what I'm looking at here is a negative sign, a subtraction sign. Do you remember what we would do? Remember, if we are doing the quotient property, if we're dividing, we subtract. So we're going backwards now, so this is going to be a division problem. So we'd have the ln of 4w over the ln of w, or excuse me, of y. Now, you can even condense it down a little bit more. Since that's common, you can just kind of like almost factor that out. So probably this is the best way to write it, ln of 4w over y. And that would be the best way to write that one. Okay. Got another one. This is the power rule. Okay, so this was the one that we had an exponent to an exponent. Remember when we took that exponent and we moved it out to the front? Well, what we're going to have to do is take it from the front and move it back to the exponent. So all we're doing here is log of x to the 8th, x to the 8th. And that's all we do. So just kind of going backwards what we already did. All right, now let's take kind of a bigger problem. Let's kind of mix a bunch of them together here and see how we can condense this one. So if you look here, what we've got going on is this looks like it's a product rule. Why? Because it's an addition sign. While this over here looks like it's a quotient rule. Why? Because of the negative sign. Do we have any exponents going on? We actually do. That's an exponent right here, so it needs to be moved back. So we got lots of different stuff going on in this one. So let's take this kind of piece by piece. Let's kind of go, I guess, in backwards order. So let's take this one first. Let's do the power rule, and let's move him back here. So we'd end up with log 3x plus, moving that back would be log 3 y squared minus 5 log 3z. All right, now what? Next thing that I would want to do is let's turn this into a product rule. Okay, let's turn that back into a multiplication problem. So here I would get log x, or well, log 3 x times log 3 y squared, and then that would be minus 5 log, oh, I forgot something, log 3z. I forgot about that one. That one is another product or a power rule, so that one would go over here. So I'll just go ahead and do that right now. I'll move that 5 over to the exponent of the z. There we go. And now we just want to deal with this one, and the way that we would deal with this one is it's a division problem. So we'll take that and get rid of that, and we'll make it a division problem. And it would be log 3z to the 5th. And there would be your final answer. That's as condensed as we can get it right there. Log 3xy squared over log 3z to the 5th. That'd be the best way to condense that one down. All right, now, notice something that's happening here in this problem, this last problem that we just did. Notice it's log 3. I haven't showed you how to do that yet on your calculator. We still don't know what that means or how to do that. So let's kind of take a look at this. In your book on page number 348, page 348, we find what's called the change of base, the change of base formula. Now, the reason why we need to use the change of base formula is because not every calculator, now a lot of new calculators, a lot of the more expensive calculators, okay, especially the graphical calculators, they can do this. There's a place for you. There's typically a button on some of them that says log, and it has a little box there, okay. If your calculator has this button, log box, and subscript, okay, not superscript, subscript box, then you can do this without doing the change of base formula. But if you don't have it, and a lot of regular scientific calculators, they don't have it, okay? It's what it says right there in the book if you read that little paragraph. They don't have it on most calculators. So how are we going to do this if we don't have a log to that button right there, log to the box? And what that box means is we can put whatever we want to in there. Yours also might say log X or something like that. If you have a log X, maybe that'll work for you. But a lot of calculators, they don't have that. So what are we going to do? Well, we're going to use the change of base formula. A couple things that are important. Don't forget that the X is our argument and the B is our base. That's very important for what we're doing right here. What we want to do is we want to take this. This is the general format. All right, and we're again on page 348. If we take the general format, this is kind of, if we just get a normal problem, this is what it will look like, okay? What is that log A right here? Well, that's a different thing. It's got a different number there. What if it has this is the common, okay? I put common over here. So these are log 10s, okay? And then you could also have it where it's a natural log, and that's with the ln right here. They're all the same. It's all a division problem. In essence, what you do is you take the log of the argument over the log of the base. Log of the argument over log of the base. All right, so what does that look like on this one? Well, what is the argument and what is the base? In this one, the argument, okay, which is x, that equals 20. And the base equals 3. So what are we going to do here? That one looks like this. We're going to put x over b. We're going to put log of x, log of 20 over log of base, log of 3. Now you can do that on your calculators. How do you do that on your calculators? Okay, so if I take my calculator out here, again, mine works a little different than yours. You're going to have to figure yours out right here. You got to figure out what works for you. But what I want to do is I want to divide log 20 by log 3. That's what I'm trying to do. The way that mine works is I have to put a parenthesis, and then I put my 20 first. So I put 20, and then I put log, and then I close my parentheses. Notice it's already starting to do some computations right there. I don't care what it's doing right there. I'll just let it keep going. And then I'm going to do the divided sign because this is a division sign. So divided by, and I'm going to put parenthesis again, and I'm going to put my 3, and then I'm going to hit my log, and then I'm going to close my parentheses. Okay, so I have log of 20 divided by log of 3. If you can see it right there. I'm not sure if you can see that. It's kind of small. Log of 20 divided by log of 3. You figure out how your calculator needs to receive those different button pushes that you're doing, and then you'll be fine. But yours is going to be different than mine. And then I'm going to hit equals. And that's going to equal 2.7268. So that equals 2.727 because it was 6.8. So that 6 is going to round up. Now, technically, that doesn't equal that, does it? Because we rounded off. So don't forget to put your piece of bacon on for your equal sign. So instead of the equal sign, we're going to put bacon right there. Okay, our equal sign looks like bacon. Why? Well, the reason why is because it's approximately, and that's the sign for approximately. It doesn't mean exactly because we had to round off. Anytime you round off an answer, you should put that bacon symbol right there. Okay? All right, let's do one more. That was so much fun. Let's just do another one. This one's gonna be a little bit more complicated because we have to do something before we can do the change of base formula on it. We have to we have to condense it down before we can do the change of base. So let's go ahead and take a look at this one. What's going on here? Well, what's going on is this is the exponent, so this is going to go here. So we're going to get log 3 of 8 squared minus, what does that mean? Divided by, and this 5 goes over here. So log 3, 2 to the 5th. All right, now what's important that we do right here is we need to solve these two. We need to do what we can do. In other words, that's going to be log 3 of what's 8 squared? 64 over log 3 of 2 to the 5th, which is, I think, 32. Yeah, 32. Now you can do a couple different things right there. I think what I would do is I would just reduce that out. That's going to be your easiest thing to do next. So you're going to get log 3 and divide that out. What do you get? 32 goes into 64 2 times, so it just comes out to a 2, or 2 over log 3, 1, but what is log 3, 1? We don't need that because it's a 1 on the denominator, basically. And so this is our answer, but it's not quite our answer because we need to do a change of base. Why? Because it's not a common base. Our calculator can't solve that. We can solve it, okay? And the way that we do it is with the argument over the base. So we would do the log of the argument 2 over the log of the base 3. And we go ahead and do that on our calculator. So log 2, so let's get the calculator back out. And we'll do, I think I can cheat a little bit here. No, it's not going to let me. I got to clear it out. So parenthesis 2 log, close parenthesis, divided by parenthesis 3 log, close the parenthesis. Again, your sequence might be a little different there. You might have to push log button first. I have to push the number first, then the log. Equals 0.639, 0.6309, or 0.631. 0.631 would be our answer to that problem right there. And that's bacon, don't forget. That's approximately. Why? Because we rounded off. Okay. All right. Well, that's all I have for you. That was so much fun. Only 15 minutes. We got through a lot in 15 minutes. If you have any trouble there, make sure you go back, rewind it, watch it again. A lot of pretty complicated stuff there. A lot of moving parts there, especially that last one where we had a lot of different things. Some reducing going on there, some subtraction, basically some division because we're subtracting logarithms, it's division, and just different things. Change of base formula had to take place there until we got our approximate answer. All right. If you missed anything, slide it back, take a look at it again. All right. We'll see you later. Have a good one. Bye-bye.